why is he thinking about wormholes? Why is he thinking about time travel? He's thinking about wormholes. He's thinking about time travel because this guy who's writing a book on contact wants to know if it's possible. Like, so what is the name of the guy who's writing a book about contact? By the way, Contact is the movie that you guys will get to watch in the next 2 days, and you will be testing on it too. So we will go over the list of the movies that you have to watch, the documentaries and the movies. All right, so what's the name of the guy? What is the name of that guy? Let's get back. All right, so that's one detail that you guys missed.
Sagan, the noted astronomer, was
What's the name?
writing a science
Carl Sagan.
fiction.
Carl Sagan. Carl Sagan. Does anybody know who Carl Sagan is? Does anybody know who Carl Sagan is? Carl Sagan. Control H. How many of you guys seen the Cosmos recently? The documentary Cosmos? All right, so Carl Sagan, you will get to watch the documentaries. This guy actually made a documentary which is about 10 or 11 hours long, and one of the first people who tried to popularize science. One of the biggest names in astronomy, as it so happens, and you will get to know him quite well. So obviously, the first movie that you will get to watch is going to be his Cosmos.
Going forward.
All right, so who's the author of Contact?
Sagan.
Carl Sagan. Carl Sagan. All right, give yourself. All right, so who's responsible for the theory of time travel through wormholes?
Kip Thorne.
Kip Thorne. All right, those of you guys pick Kip Thorne, give yourself as well. So for time travel to be possible, so two things that we established so far. Number one, the time needs to be a continuum. Number two, it needs to be curved, right? If it's flat, you're not going to be able to take shortcuts. If it's curved, you may be able to shortcut, and you may be able to take shortcuts.
Suppose a wormhole does twist time as well as space. Suppose NASA engineers were able to keep two wormholes open and connected using a repulsive gravity source. Suppose the super shuttle could navigate through the connecting tunnel. Suppose they found Elvis out there. Suppose. Cosmologists do a lot of supposing.
All right. Now, for us to be able to do time travel, obviously we will need wormholes. And for us to be able to go through wormholes, we have to stabilize. So how do you stabilize a wormhole? So it's large enough, opening is large enough, and there's not much radiation, and then the gravity is not going to crush us. So we're not going to get crushed. We can stabilize these wormholes by using something that generates repulsive gravity. So Kip Thorne is the guy who was actually considering this problem, and he knew that the solution of this problem would be using something that would generate repulsive gravity. He's coming up with these theories in 1980s, and back then there's nothing. There was nothing in physics that would actually generate repulsive gravity. There was not a single theory, and there was no single concept which was responsible for generating repulsive gravity. So he ended up coming up with something on his own. He said, let's call this thing that generates repulsive gravity exotic matter. So he came up with the idea of exotic matter. So what's exotic matter? Exotic matter is matter. It's some kind of a science fictional matter that he himself came up with that should generate repulsive gravity. Unless you have something that can generate repulsive gravity, you cannot stabilize these black holes or wormholes enough so that you can actually do time travel. So that would be impossible. And then something happened in 1990. Physicists discovered that the universe was expanding, so no surprise there. What was surprising was the fact that as the universe was expanding, it was actually accelerating, which means that it was speeding up. The fact that it was speeding up meant that something was pushing the universe in the opposite direction. Something was generating repulsive gravity. We still don't know exactly what that is that generates repulsive gravity, so we call it the dark energy. All right, so Kip Thorne's exotic matter from the 1980s became our dark energy in 1990. All right, so what is dark energy? Dark energy is what generates repulsive gravity. And so what is it responsible for? It's responsible for the expansion of the universe. While the universe is expanding, it's accelerating, which means that the universe is speeding up. All right, despite the fact that we don't know what it is, and hence the reason we call it dark. All right, if somebody says dark energy, which means that we know that it's something that generates a tremendous amount of energy, in this case repulsive gravity, but we don't know what the source of it is. If somebody says dark matter, it's a matter that you cannot see, which means that it generates a tremendous amount of gravity, but we don't know what the source of that gravity is. That's the reason why we call it the dark matter. So dark energy generates repulsive gravity, and dark matter generates attractive gravity.
Now, one of the theorems that was proven many years ago is that if you create a wormhole in a region of space where it never existed before, you must also twist time in such a way that time travel becomes possible. In other words, not only do you have created a hole in space, you must also have twisted time around so that it becomes possible to return to your starting point in space-time before you left. You automatically create a time machine when you create a... is what...
All right, so now we got problems. The problem is the time travel. Regarding time travel, problem with... No. Okay, so regarding our problem of time travel, three conditions need to be satisfied. The first condition is the time needs to be a continuum, which means that the past, the present, the future all need to exist at the same time. The second condition that needs to be satisfied is it needs to be curved, kind of like the Mobius strip. If it's flat, you cannot take shortcuts. If it's curved, that allows you to be able to take shortcuts through wormholes, obviously, if that's a possibility. And the third condition needs to be satisfied that it's going to come out of the following scenario. All right, so imagine that the time travel is possible, so I can go 100 years into the future and spend 18 hours there and come back with the next fraction of a second. All right, so the wormholes would allow that to happen. So forget about going to the future, all right, because we don't know what the future holds. But the past, we do know 100%. That's known as history, all right? You can go back 100 years into the past. You can go back 50,000 years into the past. It doesn't matter. So why don't we just go back to the past that we know and then try to make some changes? I'm talking about why not just go back maybe about 50 years into the past or 60 years into the past. Find Hitler and kill him before he starts World War II. And then what happens to the present? What do you think? So go back to the past and find Hitler and kill him. What happens to the present? So,
wouldn't it create a butterfly effect? It would change things in the present.
All right, so absolutely, right? So you go back in past and then you just find him and you kill him, and then next thing you know, the history completely changes. All right, I've been told that I sometimes lecture about students' heads, so you probably don't know Hitler is, so why don't we just make it a little bit more personal? All right, guys, speaking of Hitler, when do you think you're going to be able to find him and kill him if you could do time travel? By the time he looked like the way he did in the history books, he was fairly famous and it was extremely well protected. There's no way you can go near that. So you got to find him as a little kid, right? And so you have to find every single kid whose name is Adolf and then kill him, right? That's what you need to do. You got to look for a kid with a funny mustache. Is that what it is? No, so you're not going to be able to find this guy and you're not going to be able to kill him. So forget that. So why don't we make it a little bit more personal for you? Why don't you go back in time and find your own grandfather before he fathers your father and kill him? And what happens to you?
The paradox.
What happens to you? Go back in time, find your own grandfather before he fathers your father and kill him.
Never be born.
Never been born, right? Give yourself a point. All right, if you're never born, who goes back in time and kills your grandfather? No one does, right? So which means that your grandfather is still alive, which means that you still go back in time and you still kill him, right? And then you vanish. No one goes back in time and kills him, and he's still alive. Notice what happened, guys. You end up getting two contradictory lightning, which is known as, what is it called? It's called
a paradox.
It's called a paradox. All of a sudden, you end up getting a paradox, which means that using the same logic, you can come up with two opposite conclusions, and both conclusions are just as valid, equally valid. So it's going to give you a paradox. The problem with paradoxes is nature does not like these paradoxes. It's going to give you a grandfather paradox. This is known as a grandfather paradox. So how do you overcome this paradox? What is it that you got?
Suppose a wormhole does twist time as well as space. Suppose NASA engineers
is what's called the grandfather paradox. The grandfather paradox says, if time travel is possible, then it ought to be possible to go backwards into time and kill your grandfather before he fathered your father. Then you've got problems.
You might tend to vanish if you shot your own grandpa, but Tipler says that quantum mechanics provides a theoretical solution. Quantum theory holds that each atom goes through all possible histories. Tipler asks us to think about such a universe, or multiverse. He supposes you would have killed a copy of your grandfather in another branching universe.
In that history, which you're now in, he does not father your father. You do not exist in that history. As a young man, anyway, what you have done is you have entered that history via the time machine. Now, if we could isolate ourselves, we would also be aware that we existed in many of the universes. It's the very fact that we are, so to speak, anchored to one of these universes, because we are interacting all the time with the other atoms in this universe, that we're unaware of the other universes.
All right, so how do you overcome the grandfather paradox? All right, so this becomes the third condition that we need to satisfy. Active time travel is going to create paradoxes, especially if you're traveling back to the past. Because if you travel back to the past, you will get to alter events in the past. Altering events in the past is going to affect the present. The only way you can actually overcome the grandfather paradox, or otherwise known as the time travel paradoxes, is by creating parallel universes. So the act of time travel needs to create its own history. All right, so this becomes the third condition that needs to be satisfied. The act of time travel needs to create its own history. It sounds really, really science fictional. All right, so pick out the best answer from this one.
B.
All right, the only way the time travel, give yourself 5 points for that one. Guys, the best answer has to be B, right? The only way the time travel is possible. Backwards and forwards in time. And that's the only time travel that we will investigate. The way it is portrayed in the movie. Act of time travel needs to create its own parallel history. And that was this guy's PhD dissertation. Hugh Everett III, that's another name that you will get. He came up with something called Universal interpretation. This is the competing theory of quantum theory. The first time when you're exposed to it, it sounds really bizarre. It sounds extremely science fictional. But by the time I'm done with you guys, this explanation is going to make perfect sense. He talked about these parallel universes, otherwise known as the universal interpretation. This was his PhD dissertation, which was published in 1957. At the time of the publishing of this paper, he was the only person who actually believed in it. And today, it's a mainstream interpretation, one of the mainstream interpretations of the quantum theory.
I've heard that there's the possibility that in string theory that there are multiple universes being created at any single moment.
It's an idea that comes into the theory, also comes into theories of cosmology.
So there could be multiple us at this moment?
There is a theory that says something akin to that we're having an interview in
the
other
number
universe.
Of us,
the interview is different in these other universes.
In some other universe? Could I have nailed you just now?
I just heard that you did from the other one.
Oh, really?
Yeah.
Maybe I nailed you in this universe.
You did indeed.
Would you please come back?
Sure. Yeah, I did.
Maybe I'll understand it next time. Brian Greene, we'll be right back.
So Brian Greene is the face of the string theory. You will be watching a lot of
on NOLA.
Here's a big picture of what we will do.
Take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
No matter how many times I come here, I never seem to get used to it.
Can he help us solve the greatest puzzle of modern physics? That our understanding of the universe is based on two sets of laws that don't agree. Resolving that contradiction eluded even Einstein, who made it his final quest. After decades, we may finally be on the verge of a breakthrough. The solution is strings. Tiny bits of energy vibrating like the strings on a cello. A cosmic symphony at the heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who've said that there are extra dimensions of space have been labeled crackpots or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
The string theory fails to provide a testable prediction, then nobody should believe it. Is that a theory of physics or philosophy?
One thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
All right, so 3 conditions that need to be satisfied for time travel to be possible. Time needs to be a continuum, meaning that the present, the past, the future all need to happen at the same time. And according to Einstein's theory of gravity, that's the way things are. So the question is Einstein's theory of gravity proven to be correct? Space-time continuum needs to be curved. If it's flat, you cannot do time travel. Only if it's curved, you may be able to, by taking shortcuts through the continuum, like wormholes. Last condition that needs to be satisfied is active time travel needs to create its own alternate history, universe, so that we can overcome the grandfather paradox. So the time travel paradoxes could be overcome.